This is a Math 2 summary video for the lesson titled Summing It Up. This lesson is a practice understanding task. The purpose of this lesson is for students to create multiple representations of quadratic functions, compare the rates of change between linear and quadratic functions, and find key features of quadratic functions, interpret key features of functions in context, interpret parts of equations in context, and add, subtract, and multiply polynomial expressions. In this unit, and with this lesson, you are asked to determine what type of function you're given. To identify a function as quadratic function, you can look to see if the standard form of the function has x squared, where the 2 is the highest exponent in the equation. The graph of a quadratic function is in the shape of a parabola, meaning that it either increases, reaches a maximum, and then decreases, or decreases, reaches a minimum, and then increases. The table of a quadratic function shows a linear first difference and constant second difference. The first and second differences that you can find in the table give further insight into the rate of change. Each type of function has a unique rate of change. For example, all linear functions have a constant rate of change, where the first difference is constant. All quadratic functions have a linear rate of change, where the first difference is linear and the second difference is constant. In this unit and task, you are also asked to find key features of a function. The domain of a function lists any possible inputs to the function. In a quadratic function, these are the x values. The range lists the outputs of the function. The minimum or maximum point of the function is the ordered pair that lists the highest or lowest point of the function. Quadratic functions have either a maximum or a minimum. The interval of increase are the x values where the function or outputs of the function are increasing. And the interval of decrease are the x values where the function is decreasing. The axis of symmetry is the vertical line that passes through the minimum or maximum point of a quadratic function. The x-intercepts are points where y equals 0. This is where the parabola passes through the x-axis. A quadratic function can have 0, 1, or 2 x-intercepts. The y-intercept is the point where x equals 0. Quadratic functions have only one y-intercept. In this unit and lesson, you are asked to interpret key features of a function in context. A practical domain and range are the x and y values that make sense in the context of the problem. When interpreting practical domain, start by identifying what x represents in the problem. Does x represent a time or a specific length? Think about what input values would work in the context. Would negative values make sense? Is there a number that would be too big to be a reasonable input? When interpreting the practical range, make sure that you understand what y represents in the problem. If you already have the practical domain, find the y values that correspond with those x values. In addition to interpreting key features, there is also a need to be able to interpret parts of an equation. When doing this, make sure that you understand what the variables represent in the problem. Look at the structure of the equation. If there are groups of terms in a set of parentheses, look to see if everything in that set of parentheses could represent something from the problem. If the function involves a geometric formula, like area or volume, look for the parts of the formula, like the length and width of the shape, and see if you can match the parts of the equation to each part of the formula. For example, if f of x equals the quantity x plus 4 times the quantity x plus 2, and the function represents area, then one factor, x plus 4, could represent length, and the other factor, x plus 2, could represent the width of the rectangle. When simplifying an expression, remember the order of operations. When simplifying, start by looking for parentheses, then exponents, then multiplication and division, and then finally addition and subtraction. For example, when simplifying this expression, there is nothing to simplify inside of the parentheses, and there are no exponents. That means that we'll start with multiplication and the distributive property. And then we will identify and combine like terms. Like terms have the same variables with the same exponents. When you combine like terms, you're adding and subtracting them.